Hi, third graders. It's good to see you here, checking your equations and your DMA work. So let's get started. It's asking for the first one. We're on week 11. We're on day 4. So today's Thursday. Tomorrow, don't forget to do your DMA quiz. So just a little reminder, just to give you a heads up. So today we're looking at which equation is the same as 3 times 2 equals 6. So if we take a look at our equation, 3 times 2 equals 6, we know that we can use the commutative property, or we can switch the order of these two to come up with the same product. Now, to prove this, I could do 3 groups of 2, and 2 plus 2 plus 2 is 6, or I could take 2 groups of 3 and add 3 plus 3, and that would give me 6. Sometimes they ask you, how do you know that 2 times 3 is the same as 3 times 2? Well, if they ask you that, you can give them proof by showing that 2 plus 2 plus 2 is the same as 3 plus 3, and gives us both 6. Now, if you think about it, 2 and 1 more and 2 and 1 more from here is going to give you that 3 and 3. So basically, you're just taking the numbers apart a little differently and then recomposing them in a different way. Now, 6 times 3 equals 18. Well, this doesn't say 18. We know that that isn't true. We know that 3 times 6, 18. Again, our product is not 18. And 6 groups of 2, now all they did was they just moved the 6 and the 2, but again, I can't just move numbers around and make them equivalent to another equation. We have to make sure that when we take that 6 and that 2, we know that this is 6 groups of 2. So I'm actually doubling that from 3 groups of 2 to 6 groups of 2. If you think about what we've learned today about the distributive property. Now let's take a look at our subtraction problem. This might be a little easier to do if we use our algorithm. So if I have 301 and I subtract 89, I know that this is not quite 100. So if I were to subtract 100 from this, it would be 201. So if I over subtract, thinking, okay, minus 100 would be 201, then it should be a little bit more than 201 if I only subtract 89. So I'm using my estimating based on what they call a compatible number. If you remember when we talked about compatible numbers, just numbers that are easy and friendly to add or subtract in our head. So this is going to be somewhere around 201. So if I subtract, I can't subtract 9 from 1. So if I think about base 10 blocks, and I'm just putting this as more of a visual model. If I think about my base 10 blocks, and I have 301, I cannot subtract 9 from that 1, which tells me I need to take a 10 from here, from that 100. But to do that, that means I have to regroup that 100, which leaves me with 2 hundreds, and I'm going to take this 10 out of this other 100, and that's going to give me 10 tens here. So that leaves me with 90 once I regroup this 10 here as another. If I take one of the 10s out of here, that leaves me with 9 tens, and now I have one more 10 to subtract the 9 from. So 10 minus 9 is 1, but I had the 1 that I started with here, which makes 2. So 11 minus 9 is 2. I have 90 here left over, minus the 80, so that leaves me with 110 left. And I still have these 200s, so I have 212. Another way to think about this is if I were to take 301 and subtract 90 from here, that would leave me with 211, because 90 and 10 makes my new 100. So really what I'm doing here is I'm making this number easy to subtract. And so if it really was 89, I've over subtracted, so that means I would have to add 1 back in once I subtract. And that would give me 212. Because I over subtracted 1 here to make this easier to use mentally in my head. So over subtracting by 1, that means I have to re-add it in. Our next problem has to do with circle the rectangle. Now remember, we have quadrilaterals. Now we're looking for the specific quadrilateral called rectangle. Now if you know anything about a rectangle, it has 2 pairs of parallel sides, and these sides happen to be equal, and we have 2 opposite pairs of parallel lines, and so there's 1 pair of parallel lines and 2 pairs of parallel lines. Rectangles also have what we call square corners, or we call them 90-degree angles. So this rectangle has 2 pairs of parallel sides, 2 pairs of equal sides in length, 2 pairs of lengths. So the width of this side and this side are the same. The length of this side and this side are the same. So this is my rectangle. Now, I bet you didn't know that a square could also be a rectangle if we follow what it says about a rectangle. So we said a rectangle has 2 pairs of equal sides. Well, a square has 2 pairs of equal sides, but it's special because unlike a rectangle, a square has 4 equal sides, but it still follows the rule of a rectangle having 2 pairs of equal sides and 90-degree angles, which are square corners. So this square could be a rectangle, but for right now, we're just going to classify our rectangle as this shape right here. This would be a rhombus, so we know that is not a rectangle, although it is a quadrilateral. And this is also a rhombus. This has 4 equal sides, and this has 4 equal sides. That's what makes a rhombus and a square similar. They have those two. They have that in common. This is a triangle, and it's actually an equilateral triangle because all the sides are equilateral. And I have a hexagon, which is a 6-sided figure, and this is a regular hexagon because all the sides are the same. We're looking for one group of 8. Our product is 8. 5 groups of 2 is going to be 10. And 9 groups of 2 is going to be 18. Or if I do 2 groups of 9, 9 plus 9 is 18. So I'm using the commutative property to help me make it easier to use. That's it for this week. Remember to take your DMA quiz. I'm going to give you today a discussion question. So what I want you to do is I'm going to focus my discussion question on circling the rectangle. However, I'm changing this up a little bit. I want you to tell me how a rectangle and a square are the same in your discussion. So again, I'm going to repeat. In your discussion question for today, you're going to tell me how a rectangle and a square are the same. If you don't remember, rewind and you can revisit or re-listen to how I described a rectangle and a square being the same. So put that in your discussion for your comments, and I look forward to reading those this afternoon after class. Bye, guys. Have a great day.